In this video, let us study some of the pathways in the Pons. Pons is associated with all the three cerebellar peduncles. The middle cerebellar peduncles begin from here, whereas the superior and inferior cerebellar peduncles descend from the midbrain or medulla to reach the cerebellum, so they will be associated with the Pons. If you take a section of the Pons at the lower levels, we will see both inferior and middle cerebellar peduncles. And if we take the section of the Pons at the upper levels, we will see the section of both superior and middle cerebellar peduncles. We have already dealt with the inferior cerebellar peduncles in one of our videos on the medulla. We will deal with the superior cerebellar peduncles at a later stage. So now let us look into the middle cerebellar peduncles. Middle cerebellar peduncles are also known as brachium pontus. They are made up of entirely afferent fibers to the cerebellum belonging to corticopontocerebellar pathway. These fibers start from one of the lobes of the cerebral cortex as either frontopontine, paritopontine, temporopontine, or the occipitopontine fibers. They descend through the corona radiata and internal capsule. In the midbrain, the frontopontine fibers descend through the medial part of the crus cerebri, whereas the other three group of fibers descend in the lateral part of the crus cerebri. After they reach the pons, they relay in the pontine nuclei, which are located within the basilar pons. We know that cerebral cortex has a contralateral representation and cerebellar cortex has a ipsilateral representation. So the fibers which are starting from the cortex before they reach the cerebellum have to cross over. So the fibers which start from the pontine nuclei cross the midline. They continue as the transverse fibers in the basilar pons, join together at the lateral end of the pons to form the middle cerebellar peduncles. So what is the surface landmark for the middle cerebellar peduncles? It's the exit point of trigeminal nerves. So whatever fiber bundles you're seeing lateral to the exit of the trigeminal nerves, that is what we call as middle cerebellar peduncles. The fibers in the middle cerebellar peduncles project to the neocerebellum as mossy fibers, and they are concerned with fine coordination of the movements. Now coming to the trigeminothalamic pathways for the touch and pressure modalities. The fibers carrying the touch and pressure sensation from the head region travel in the trigeminal nerve. They have their first order neurons located in the trigeminal ganglion or the Gasserian ganglion. After they reach the pons, these fibers ascend within the pons to relay in the principal sensory nucleus of the trigeminal nerve. So the neurons in the principal sensory nucleus will form the second order neurons. From here, the fibers which begin, most of them cross the midline as forming the ventral trigeminothalamic tract. These fibers will join with the medial lemniscus, although some of the authors believe that they join with the trigeminal lemniscus. They ascend and reach the thalamus, where they relay in the ventral posteromedial nucleus of the thalamus. So the neurons of the VPM nucleus will form the third order neurons. From the VPM nucleus, the fibers will travel in the internal capsule and corona radiata and finally relay in the primary somatosensory cortex, that is area 312, where they'll be reaching the head region in the sensory homunculus. While most of the fibers cross the midline, some of the fibers from the principal sensory nucleus will ascend on the same side as dorsal trigeminothalamic tract, and they reach ipsilateral thalamus and from there on ipsilateral cortex. So this pathway will be carrying the touch and pressure sensations from the head region. Now coming to band of lemnisci seen in the pons, we see a band of lemnisci located just posterior to the basilar part of the pons. From medial to lateral side, they include the medial lemniscus, trigeminal lemniscus, and the spinal lemniscus, which are transiting through, and the lateral lemniscus, which is beginning from the pons here. At the level of pons, the medial lemniscus is made up of 4 sets of fibers. It is made up of the dorsal column pathway fibers, which are carrying the discriminative touch, pressure, vibration, and conscious proprioception sensation from the contralateral half of the body. In the medulla, it will be joined with the fibers of anterior spinothalamic tract, which will be carrying touch and pressure sensations from the contralateral half of the body. Within the pons, it will be joined by the solitariothalamic tract fibers, which will be carrying taste sensations from the contralateral half of the tongue and the pharynx. It will also be joined by the fibers of ventral trigeminothalamic tract, which will be carrying touch and pressure from the contralateral half of the head. The last two tracts will have joined the medial end of the medial lemniscus. So within the medial lemniscus, the somatotopy will have head region fibers being located in the medial side, the sacral fibers located laterally. Now coming to the trigeminal lemniscus, this is carrying the fibers which are starting from the contralateral spinal nucleus of the trigeminal. They carry pain and temperature sensations from the contralateral head region. Spinal lemniscus is basically made up of lateral spinothalamic tract fibers. It is carrying pain and temperature sensations from the contralateral body. So again, between the trigeminal and spinal lemniscus, we have a second somatotopy with the head region being represented medially and sacral fibers laterally. Now lastly, coming to the lateral lemniscus, it is mainly an auditory pathway tract. However, the vestibular fibers will also be accompanying the lateral lemniscus. We will deal with the auditory pathway in a later video. We have already dealt with the medial lemniscus, trigeminal lemniscus and spinal lemniscus in the earlier videos. Thank you very much. Hope you enjoyed this video. You can visit this site for other neuroanatomy videos. We go on to study the auditory pathway in the next video. Thank you.